Hello there, my name is Jack,
My name's Tyler.
and today we're going to be presenting our Data 301 project. We did ours on golf in the PGA. So I'm going to share my screen here. Share.
All right, so starting off, we have our big question. Basically, we wanted to see if we could create a regression model that would help us predict who would win in the next Masters tournament for the PGA Tour. And so to do this, we used two different CSV files at the beginning and then one more at the end. But the first two we used, one was PGA player data that stored information about all the players, and the other one was a CSV file holding all the courses that these players were playing on, giving us some more information about how the courses differ from each other. Had to do some cleaning of the data definitely to be able to connect our two data sets. So as for the data sets, the cleaning that we had to do, we had to clean up the names of the courses in both the player and the course data tables so that we were able to connect them and use a pd.merge that we were able to have all of the course information for each player. And yeah, so then in doing this, we set up some regression models in order to do some analysis as to find who would win in the next Masters tournament. So starting off, we have our data sets that we imported. We created a GitHub so that they would be able to access on any different computer. Changed all of the course names to uppercase. Had to do a little bit of shading because some of them had locations. Had to drop some columns on some of the data tables. But in the end, we had a data table that looked like this. So it essentially just holds all the information about the player in that one given round. We have our courses, which you can see the index is the actual course name, and then our merged, which here we have a player, and this is the round they played. And at the end, you can see some information about the course that they played on as well.
Yeah, so first thing we started out by doing is we said, okay, let's take a look at some of the data and see if any of these would be good models to use to predict in our later future models when we want to predict the winner. So first thing I did was I was testing, how do the holes that a player sees affect their overall score? So first thing I did was I took all these your scores you get on par three, scores you get on a par four, scores you get on a par five, and added them to your adjusted score. We did a regression model for that, which did pretty well. R squared of 0.9. But when you really think about it, of course, the score you get on each hole of your round, of course, that's going to affect your overall score. So we didn't think that was going to be a very good one. And then I made these plots, which obviously it looks pretty linear. And then so I said, okay, let's get into a player's mental. Let's see how the strokes gained on the shots leading up to your putting affects your putting. And so I built a couple of models and it did terribly, really bad. You can see that just a straight linear model would have predicted it better. So we decided not to use this. So then Tyler looked in some other features that we could use to predict how well a player does.
Yeah, so using our merged data frame, which again holds information about the player and the course that they were playing on, we extracted from the player data the number of rounds they played, the purse, which is basically just how the stakes that were for the tournament, so how much money they could make, as well as total DKP and total FDP, which are DraftKings and FanDuel predictions. And so these are obviously from someone else that have these strong algorithms to find these predictions. So we figured they'd be good to add since they would be very accurate and good distinguisher between the different players. And then from the course, we took the par for all 18 holes, the yardage, and then just kind of where scores are gained. So like putting versus off the tee versus approach. So just kind of different areas that show which different parts of the course are harder. And so for this one, we created a voting regressor, which was just able to combine the linear and the k nearest neighbors. We created a scaler, but decided not to use it because we felt like there were some things that were definitely more important than others, such as the DraftKings and the FanDuel picks. And so we wanted those to not be scaled down. And so in doing this and creating a regression model, we ended up with a R2 score of 0.98, which is a little suspiciously high, but I think with these DKP and FDP features in our regression model, those were kind of really what carried it. And it kind of makes sense if you think about where we got those scores from. And so using this, we figured that this was probably going to be our best model for predicting who's going to be winning the Masters tournament. And so this year, the Masters is going to be played at Augusta. So we created a new data frame that basically just holds all of the merged players that had played on Augusta. And so this is kind of really just the only information we cared about. And so with this, we decided to try with a stacking regressor, see how it worked. And because the data set was a lot smaller, the R2 score was much lower at 0.8. But considering for golf, kind of how much it varies, we figured that was still pretty accurate. But from that, we thought we could maybe try a different regression model, which is what Jack did after this.
Yeah, so then I said, let's switch to a voting regressor because that worked pretty well for us the last time. We got up to a 0.85, which is pretty good. Again, using these features that we found out were good to predict on before. So then, okay, so we said, okay, so now we have this regression model. We tested it, got a 0.85. Now let's actually try and get our rankings and our scores. So these were the rankings we got based on our testing data. So we got these, our testing data was only 20% of the actual data of all the players who have played there. So what we did next is, okay, so we know that our model works well. Now we want to do it for all of the players so we get a ranking of everyone, not just the people in our testing. So, sorry, I did that later. The first thing I did was we wanted to see if we could use our model, where our model is going to give us all of, the rankings for all the players, and we want to see if we can use odds that DraftKings had put out and see how much money would have made based on what we predicted. So I found this website here. Also, our data for this was based on the 2022 Masters, so we used the 2022 rankings or the odds. So I found this table here, which gives you all the players, their odds if they were going to be a winner, their odds if they're going to end up in the top 5, and their odds are going to be in top 10. So we have most of the players here. If you do an inspect, you can see here that all this is held in a big table, and then each of these are table rows, and then within the table rows you have TDs. So if we go back over here, so first thing I did was import request and Beautiful Soup. We got our URL here that links to that page. Using that inspect element, seeing the HTML, we were able to see that, okay, we want to get all the table rows. So we did table rows, we did find all on the Beautiful Soup of the table rows. And then within those table rows, we wanted the TDs because those gave us the name, the winning odds, the top 5 odds, and the top 10 odds. So we extracted all of those here. We were putting all of these into a list, and then once we put that in a list, convert it to a data frame. We had the names, win odds, top 5, top 10 odds. So you can see we ended up with a data frame here that matches almost exactly to that table we had. So we have successfully web scraped. We have all of our odds for all of our players. So now this is when we said, okay, so now we have all the odds for the players. Now we want an actual data frame with the rankings for every player, not just from our test data. So that's where we did this. So we did basically the same thing we did above with our test data, but now it's for all the players. And then based on that, we wanted to get our actual winners. So our winner, our top 5, and our top 10. So that's what we did here is we just extracted all that from this this data frame. So these were the actual players who won in 2022, not our actual predictors, the actual players who won. So we extracted each of those. So you can see here that these were the actual winners. So Scotty Scheffler got first. These guys got 5. These guys got top 10. And then you can see that here was our predicted. So we had Cameron Smith. We predicted him to win. We had for the top 5, we had Scotty Scheffler at second. So that was pretty good. And then these other players for top 10. So now we have our rankings for our predicted, our rankings for the actual, and then our odds for each one. So we wanted to say, what if you looked at our predicted and you placed bets on all of our predicted, how much money would you have won? How well would you have done? So we decided for each bet, we're going to do it to $100. We said, okay, what if you put $100 on the winner, which we predicted Cam Smith. So Cam Smith, I think he was plus 1,300. So if he had won, you would have won, I think, $1,400. But he didn't win. So you had $100 because he came in, I think he did pretty bad actually, but Scotty Scheffler won. He beat him. So we didn't get it right. We lost $100. And then just to go over betting odds again, in case people who are watching this are familiar, the plus whatever it is tells you how much you will win for every $100 you put on. An easier way to think about it is that like a plus 300 would be like a 3-to-1 payout. So a plus 100 is a 1-to-1 payout. So that's kind of how we did our calculation. So if we look at if we put $20 on each of the top 5 players, we got our top 5 players, we got each person out, and we said that if they were in the actual top 5, we got it right. So then our odds are we get to the odds table, we locate that player, we see how much their odds were. We get that out here, and then we add on that odds divided by 100 because that gets us the payout, and then we multiply that by 20, which is how much you put on. And then we keep totaling it up for every player we got right, and we end up getting $126. So we would have won $126 if you put $20 on the top 5 players. So you would have won $26 really. And then we did the same thing for the top 10. So basically the same thing here, but now we're looking at the actual top 10 and our predicted top 10. We're seeing if that's in there. And then this time, you're taking those odds, we're pulling that out of that data frame, dividing it by 100, and then multiplying it by 10 to get you how much actual money. So this one did a little better. You would have won 164. So we put in $10 for 10 players. So you put in $100, you would have won $64 back, or a total payout of $164. And then we just want to say, what if you looked at our odds, you saw, okay, Cam Smith, it said he was going to be first. Scotty Scheffler, he did second. I really like Scotty Scheffler. I'm going to put my money on him to win first. You would have won $1,500, which is pretty good. So yeah, that is a general overview of our project. I think we kind of, we shifted from wanting to predict the 2024 Masters to kind of predicting how much money you could make on our model with these betting odds, which I thought was pretty interesting. I think it added a cool element of the web scraping. It was hard to try and find the betting odds for this year's 2024 Masters because those haven't really been released yet because it's still pretty early. I think it happens mid-April. But I think this project, as we worked through it, it kind of shaped and morphed into something that became really interesting to us. Remember to always gamble responsibly. And, this is not legal advice. Don't quote us on any of this. Please don't sue us if you use our model to place all your life savings on anything. So yeah, thank you.
Thank you.